It's fairly rare to see a new product in the surveying industry that is as innovative as what was recently released by Rothbucher Systemes. Rothbucher Systemes is a company based out of Germany that has been making data markers, targets, and prisms for the last 20 plus years. I recently came across a new product line of theirs that really caught my attention. They call it the one-point-fits-all system. The crux of what makes this system of prisms and targets so unique is its ability to quickly and accurately mount to a vast array of different surfaces. The engineering and thought that went into this design is impressive to say the least. Today I'm going to go over a few of their products, do some accuracy testing, and show you how you can save money and increase accuracy all while getting the job done faster. For this video, I'm going to focus on comparing the RS system to traditional methods for setting scan targets for terrestrial and SLAM scanners, but keep in mind all of these tools are just as useful in setting up control and monitoring networks, and RS also carries some layout tools that are extremely impressive for construction surveying as well. At the heart of the one-point-fits-all system is a stainless steel disc that allows the prisms and scan targets of this line to lock into place securely and accurately via the magnetics in the accessory of choice. The disc is stainless steel, but it's also a special blend that allows it to be rust and corrosion resistant while still being magnetic. While being able to shoot in a prism and swap it for a scanning target with the exact same HT in a matter of seconds is extremely valuable, the really unique aspect of this system is how the stainless disc that holds the accessories can be mounted in so many different ways. They can be held onto walls, floors, ceilings, or literally any flat surface you can think of by either using wood screws, concrete screws, double-sided tape, or adhesives depending on what you're trying to mount it on. The standard stainless discs are relatively very inexpensive, with the idea they could be mounted permanently and left on site for repeated use throughout the life of the project. The prism comes off and is kept safe with you where it can be used elsewhere on other jobs, but the mounting disc stays securely in place for repeated use. There are numerous options offered by RS that combine the stainless steel discs to suction cups, floor stands, anchor bolts, anchor sleeves, electrical outlet adapters, and many more. There is a means to attach the disc to almost any kind of surface you can think of, permanently or temporarily. We'll take a look at some of the different mounting options of the one-point-fits-all system, each tailored to a different application with their own pros and cons. Let's start off by looking at options that are suited for very quick implementation. The RSSV X90 is a high-powered suction cup that can be used inside or outside on any smooth surface. The main benefit of this mount is it takes about 5 seconds to set a very stable control point, and you aren't leaving a damaging mark anywhere. I personally do a lot of as-built scanning and control work where our clients don't want us marking up the floor with scribes or nails, and pencil crosses tend to get erased too quickly from people walking over them or forklifts driving on them, for example. Not to mention, putting a prism or scan target on the ground inevitably seems to attract machinery or vehicles that somehow cannot seem to get around them. When I use the suction cup up on a window or piece of furniture or steel column, I can set it faster than the little cross on the ground, and I know it will stay there out of the way until I release it. RS did a test on this unit, leaving it outside on an exterior window where it remained in the exact same position for 8 months until they finally removed it. I was curious at what kind of weight it could support, so even I was able to stand on it without it coming undone. That's 230 pounds that is supported. Another quick to set mounting point they offer is their floor stand that folds up small and deploys fast without leaving a permanent mark. I love using the stands in situations where I want to set a lot of scan control very fast. Each scan control point takes me about 15 to 30 seconds to both set and tie in with the total station. Before I had these, I would have to set a nail or other well-defined control point, shoot that in with a prism pull or mini, then swap that out with a target pull and paddle. And because target poles are not nearly as portable, I would either need a helper carrying poles for me, or I would have to bump poles around one at a time. I've noticed a time savings of anywhere from 3 to 5 minutes per point. Considering on some jobs I may set as many as 50 plus scan targets per day, that's a potential time savings of up to 4 hours in a single day. Not only is your accuracy going to be far superior because the scan target is falling exactly on the same mounting point as the prism that was used to tie it in, basically giving us an HT of 0, but I'm also not having to set and leave a ton of concrete nails or permanent marks all over the place that some clients do not care for. The next mounting option we're going to look at is just as fast to deploy as the last two, but the benefit of the RSFP X90-30B is that it turns any interior or exterior non-GFCI electrical outlet into a permanent control point. Just plug it in, throw on a prism, take your shot, then swap out the scan target or whatever accessory you'd like to use that mount point for. But with this option, I can come back to this outlet in 2 days, 2 months, 2 years, and know I'll have an accurate, easy, accessible control point waiting for me. How accurate? We'll go over the accuracy testing I did on this and the other mounting options in just a few minutes. If we're after a permanent but removable solution that can be used on rock, concrete, brick, or other masonry surfaces, there is the RSFP X90-21. This is basically an anchor bolt with a stainless disc attached to the top. Simply drill a 7/16 borehole, insert the anchor bolt, and tighten the Allen key head to expand the anchor bolt sleeve. I like to use this when mounting to an uneven surface like shotcrete wall, or if there happens to be a conveniently placed boulder. What about if you're going to a project that already has conventional control setups such as concrete nails, scribes, or rebar? RS makes a 5/8 female adapter that integrates the standard disc onto any standard 5/8 survey stud. This allows you to completely integrate from and to the one-point-fits-all system at any time. And if you use the standard stainless disc on the ground, you can treat it as a typical control point. I like to set them in sidewalks or curbs with concrete screws, and the screw head provides a nice dimple that allows the tip of the prism pole to fit into. Besides the one-point-fits-all system, RS also uses a magnetic pot mounting option. I find this very handy for setting an unobtrusive control point that you can come back to at any time. Equally as fast as the other options we've looked at, but like the outlet option, this allows us to set a permanent mark to come back to over and over. Not only that, but if you're using it on a horizontal metal surface, you can easily set a point that you can later use to set up an instrument, rod, or tribrac over. I like to use a center punch to create a small dimple that I center the magnet over and place the prism on the magnet, take my observation, then swap the prism for a scan target that uses the same magnetic pot mounting system if that's the accessory I'm looking to use. I also really like this option for a quick common control point. I can set them up above obstructions where they won't get disturbed, and my line of sight is a lot less likely to get blocked. These have really tightened up my common point control networks in a big way. There literally isn't any other option on the market that can match it in terms of speed and accuracy for that application. If you have a handful of these, they make fantastic resection points, and considering you can buy a handful of these for the same price as a single Leica prism, tripod, and tribrac, it's not a bad option. RS makes a wide array of accessories to go with these mounting options. They have tiltable black and white round targets in different sizes that are perfect for scanners, like the Leica RTC 360, and I can tell you from personal experience, they picked up extremely well in the automatic target recognition in the post-processing software. They also have reflective targets made specifically for terrestrial scanners that prefer this style of target, such as the newer Regals. They have square black and white targets that are made for SLAM units like the VLX, where you can not only pick the target out of the point cloud as a check, but use it to physically align your control point to. They make sphere targets, aerial targets, mobile scanning targets, targets optimized for automatic target recognition, and numerous kinds and sizes of prisms for any situation you can think of. Time for the million-dollar question. What kind of accuracy are we looking at here? Not many manufacturers go to the trouble of having an independent association create a white paper on the accuracy of their equipment. In fact, I would go as far as many, not all, manufacturers hide behind accuracy specs that they list, but never explain what those values actually mean or how they were derived. Luckily for us, RS took a very different approach when they sought the assistance of the geodetic laboratory of the Chair of Geodesy at the Technical University of Munich, who tested 7 different models of the RS prisms, checking for prism constant accuracy, also known as the addition constant, target centering accuracy of the mechanical rotation action of the prism, and measurement distance ranges. The study used 3 random prisms for each model off the production line to test continuity and quality control. I'll leave a link to the white paper in the video description, but to summarize it very briefly, all prisms tested were within 1 millimeter of error in every aspect tested, often significantly better than that. This was extremely impressive considering what we saw in my previous video surveying 101 prism selection. If you haven't seen it yet, check it out after this video. So we have prisms that on their own are as accurate as some of the best you can buy and far outperform the vast majority of prisms out there. But we cannot ignore the benefits that this mounting system provides. We are basically removing all pole plumbness error. But does the optical center of the prism align accurately with the center of the target when we swap the two on a mounting disc? And what about centering error? Is it also basically eliminated as the one-point-fits-all system has extremely tight tolerances? The white paper already tested the swiveling action of the prisms and the quality of the glass, but I wanted to test how precise the electrical outlet mounting point is, how stable the floor mounting option is between swaps, how well the targets align to the prisms, and the centering error when taking a prism off a disc and putting it back on in a different orientation. So I set up a total station with a distant, stable backsite with 4 discs nearby. One was the control, a stable prism that didn't move for the duration of the testing. The second was also a securely mounted disc, which after each round of observations, I would take off the prism, rotate it, and adjust the angle and put it back on. This should show any slop in the mounting system, swiveling base, and the rotation of the prism. The third was also a secure fixed point, but between each round, I would take the prism off and replace it with a target that I would shoot in reflectorlessly. This is testing the alignment of a prism to a target. The fourth point was a floor stand. After each round, I would take off the prism, adjust the rotation and angle, and replace it. This would test how stable this system is when swapping out accessories. I also set up inside a building to test the electrical outlet mounting point. Between each round, I would remove the mount from the wall, pull the prism off the mount, adjust the orientation, and replace both. This tests how precise I could expect this mounting system to be when I used the outlet as a control point. I took 6 rounds of 3 sets of observations for each point. I was legitimately shocked once I brought the coordinates into Excel and started digging through the data. The RS prism I was using as control had the exact same deviations as the very best Leica prism I tested in my prism selection video. The standard deviation in all 3 axes between 6 observations were a single thousandth of a foot or a third of a millimeter. And remember, all of these numbers include the error of the instrument. The prism that I removed, altered the orientation, and put back on the fixed point had a standard deviation in all 3 axes of 2 thousandths of a foot or 0.6 millimeter with a maximum deviation of 5 thousandths of a foot or 1.5 millimeters. When I did the same operation on the floor stand, there was a standard deviation in all 3 axes of 1 thousandths of a foot or 0.3 millimeters with a max deviation of 3 thousandths of a foot or 1 millimeters. I'm chalking up the change between those two as instrument error, as theoretically I would have expected to see more deviation in the floor stand. Based on these observations, I could deduce that the centering error of the prism and mounting system is around 1 millimeters. Try setting up a prism rod or tri-back and tripod, taking a shot, pulling it off, and replacing it 5 times and getting a precision of every single shot under 1 millimeters in 3 axes. I'll tell you right now that's not going to happen unless by pure luck or using very specialized tools with an extremely competent surveyor. And remember, it takes me a couple of seconds to set one of these prisms over a control point, and I can carry the whole system in a pocket. I'm not lugging around a 20-pound tripod, tribrac, and prisms and spending a minute setting it all up. When I swap the prism with a target, the two differ by only 0.004 of a foot, or 1.2 millimeters, when I averaged 3 observations to each. Considering the instrument I used had a reflectorless EDM spec of 3 millimeters plus 1 ppm, and this deviation is well under that, I could not say that the target and prism aren't perfectly aligned. Again, this is extremely impressive. Going back to the example of setting a traditional control point, shooting it in with a mini or tripod and tribrac, and replacing that with a paddle point, there is just no way you're going to see that kind of accuracy with traditional equipment. When I moved inside and pulled out the electrical outlet mounting point and removed the prism, changed the orientation between each round, I saw a standard deviation in all 3 axes of 0.002 of a foot, or 0.6 millimeters, with a maximum deviation of 0.006 of a foot, or 1.8 millimeters over 6 rounds. This one was the most surprising to me. I was already sold on the speed and convenience of the outlet adapter, but I thought for sure I would be sacrificing a fair amount of accuracy with it. To see the maximum deviation of under 2 millimeters for 6 observations, I still believe I would have an extremely difficult time matching that accuracy using traditional means. Using a high-precision mini tripod with a very high-quality prism on a control point, with some level of force centering like a concrete nail with a dimple in it, it may be possible. When we're scanning inside and can't set control on the floor for a variety of reasons, we tend to use adhesive black and white targets. The person setting control will usually go in first, set the adhesive targets where they feel they are needed, then start traversing and tying all the targets in with the person scanning working in behind them. On the surface, this seems like a fantastic option. The targets are easily placed and removed, they aren't going to move on their own, and they are relatively cheap without permanently hurting the surface that they are applied to. But there are a few key issues with this method as well. The targets unfortunately don't always stay stuck on all surfaces. There's been many times where I've set them, tied them in, and they fell down, but even more importantly, they need to be shot in reflectorlessly. In perfect conditions, RL observations usually carry 2 or 3 times the amount of air from the EDM. But as numerous studies have shown, as your angle of incidence increases, so does your air. The University of Southern Queensland did a fantastic job on their study where they observed errors associated with reflectorless total station measurements. I highly recommend anyone that uses RL to give it a read. At a 30-degree angle of incidence, they observed an average error that was about double that of perpendicularity, and at 60 degrees, that climbed to 6 times what it was at perpendicularity. And it is not uncommon at all to be in a tight interior space on these as-built scan jobs. Trying to get a perpendicular shot on flat targets can be a massive expenditure of time and effort. We also have to consider that we must manually point the instrument when we're shooting in anything in reflectorless. This adds a significant amount of time to every shot from both pointing multiple times on both faces, or especially if you're running rounds, but you also physically have to walk back to the instrument every time you want to dig a shot. Any way you slice it, the RS system is a massive improvement of efficiency and accuracy to what is the currently accepted way to set control and scan targets. Imagine doing an interior scan and having the ability to turn every single outlet into a highly accurate permanent control point. Not only that, but it's faster, cheaper, lasts longer, and is much less likely to get disturbed than what you're doing now. If you need a permanent point where there isn't an outlet, use a mounting disc. Just need a quick target and don't want to set a disc, use the floor stand. Worried about someone walking into it, place it under or on a piece of furniture. If all those options don't work for whatever reason, use a suction cup or any smooth surface. If there's any metal around, use your magnetic option. Of course, there were some things about the RS system that I thought could have been improved upon. I'm used to Leica targets and prisms that are full metal construction. The RS system uses plastic. It seems very durable. I've never broken one to date, but metal would have been nice. That being said, a Leica 6-inch target costs over $600, and a comparable RS target costs less than a quarter of that. It's much lighter and maintains the same or better accuracy. So would I rather have 4 targets for the price of 1 and live with it being plastic? Absolutely. I reached out to RS to ask about this and was informed that this specific compound of plastic was chosen over metal to reduce the thermal expansion and contraction of their prisms and targets, and for its UV-resistant properties. And given the accuracy I'm seeing is as good or better than every other metal prism I've tested on the market, maybe they're onto something there. The outlet mounting point works amazingly for 95% of the outlets I came across. It fits very tightly where I wouldn't want it to be any harder to install or remove, but at the same time, I wouldn't want to sacrifice fit by making it any looser. But GFCI outlets are a slightly different dimension because they have to fit in the test and reset buttons in the middle of the outlet. This isn't a huge deal because you'll only really find GFCI outlets in bathrooms or outside in the open, and in both situations there are plenty of other options in the system you can use. Like I mentioned earlier, I'm a huge fan of the magnetic pot mounting system. I may be biased here because a lot of the jobs I do are inside around machinery where there is always an abundance of steel around, but being able to set a permanent, extremely accurate control point very quickly on walls, columns, or equipment where I can pop the magnetic off when I'm done and come back the next day and the mark is still there, this is just very handy. I do wish they had a similar way to mount their one-point-fits-all system via a magnet. The suction cups do work on almost all metal surfaces as well, in my experience, but with the suction cups, when I do remove them, I cannot come back later to that point as there isn't a demarcated center point left behind. So what I did was I super glued some extremely strong rare earth magnets to some of the stainless steel discs and used those in the same way as the magnetic pots. I set a dimple or pencil cross or scribe on a steel surface, then simply set the disc and magnet centered over the mark. The magnets I got never move when I don't want them to and can actually be pretty difficult to remove, so I suggest having some kind of tool to pop them off rather than sliding them to an edge. I'll leave a link in the description of the ones I got off Amazon, but any similar magnet should work fine. It took me 5 minutes to make 10 and the glue has held up fine. There has been more times than I can count where I wished I could have set a point up above obstructions on a power pole, lamp standard, tree, column, or other round object. I've used L-bar prisms and lag bolts in the past on wooden utility poles. They work okay, but changing orientation is a real pain and you have to leave them up there attached to the pole. At the time of filming this video, I've learned that Rothbucher Systemes is actually in development of a mounting system for round objects, so I'm very eager to see what they come up with on that front. I've barely scratched the surface today on the RS system. Like I said, they have a ton of mounting options and accessories beyond what we've looked at today, and I will dive deeper into the rest of their product line in upcoming videos. If you're looking to purchase some of their accessories or one of their kits, I believe Bernston and SitePro carry some of their products, but they're continually adding new distributors, so your best bet is to contact RS directly to find a distributor near you. I hope you enjoyed today's video, and as always, subscribe if you want, like if you feel it's warranted, and I'll see you next time.